Yes, sir.
Yeah, I can also hear it. So recording, okay, recording has started finally. So we have this 491 cloud computing course, and I have already discussed. We'll just quickly go through for the course information. I have shared the handout with you so that it will help you decide to join the course or not. Grading scheme I have already discussed. We will have a midsem exam and end sem exam 40% each, and then lab and assignment work will be 20% weight. Um, so the course plan is to tell you about cloud computing from three different perspectives. If a developer is using some service in the cloud, how will he or she do it, right? So those aspects, how what the developer needs to think or take, be concerned about things that he should take care of while using a cloud computing service. We'll discuss about those things. Then architecture perspective, how an architect will solve a larger problem using combining different cloud services that are available. That is another aspect we'll cover. And some aspects will cover from IT perspective, like the networking guys, right? That reminds me of a very important thing that I want to tell you. In in India or our society, what we do is we get pushed into BTech computers in hordes, right? Obviously, not everyone is tailored in their brains to be logical and be a programmer and all. So I have seen many people struggle to become programmers. Fortunately now, not at the time when I was doing BTech. Now there is a lot of there are a lot of career options where you don't need to be really a full blown programmer, right? Clouds IT infra guy or IT infra person or IT infra skills is one such area where you need to understand how cloud operates, how the networking can be done, how the access management is done, how the DevOps is done. DevOps means how the system uh, works, where you can release the software from starting to code to all the way releasing it to the customers. Everything gets automated, gets through a process that's called DevOps. How DevOps is done, build management system that is part of DevOps. Okay, uh, costing. Cost is one of the most important things which we generally ignore. That is very important thing to consider. So there is a career option in cloud which for people who do not have natural talent of thinking logically, therefore cannot be good programmers. They Such people are no way lesser than people who can be programmers. Okay, because their mind works in a different way, just that the direction is different. So you can opt to become an IT professional in cloud by mastering the skills that are required there, where not much of programming will be involved. You will write some scripts, some templates and stuff, but you will be able to handle it much more easy. So that is why I have included this uh, IT perspective also in the course plan. Okay. Um, if any one of you thinks that this could be useful for him or her, let me know. I can guide you more. Probably will may not cover everything that is required, but I can definitely guide you. Uh, to start with, you should understand the networking in cloud computing. How you can set up networks. Your networking concept should be clear. The masking of IP address and stuff like that. VPN, virtual private network setup. Um, so such things. Okay. Then cloud service providers, Azure, like I said, many times I will discuss about or take examples from Microsoft Azure. I have already explained you the reasons, but many places we will cover what is the equivalent in AWS at least, Amazon Web Services. And obviously, as you would can understand, we cannot cover, um, you know, every cloud service. Also, it is not appropriate. When I was doing this course or giving this course in the beginning, I was putting equal emphasis between Azure and AWS service. I will discuss an Azure service. I will also discuss then the equivalent service in AWS. The feedback that came from that was that it is too confusing. So then I started only referring to AWS just for, to give you a perspective, but focusing more on Azure so that we do one thing properly. Okay, so Azure will be our primary service provider technology or cloud service provider that we'll use. But definitely we will cover AWS many places. Uh, there is no single reference book. These are the links that I will share. They are basically, documentation links of cloud service providers. For doing practicals, feel free to use AWS or Google Cloud or Azure. I think if, for example, there is a generic problem, if I tell you about a tutorial in Azure, then either you find an equivalent in AWS and submit, that is also fine. But if there is a general problem like NoSQL as a database design or something, that you can do in any of the cloud. Google Cloud fine, AWS is fine, Azure is fine. But what I will suggest, I think, is better to focus on or use one cloud properly. So if you pick AWS, then use it properly. Learn everything about AWS. If you pick Azure, learn everything about Azure properly. Okay. Um, I will recommend Azure because I think for learning purposes, Azure is much better. It has got a lot of documentation and very sorted. But feel free to move to AWS and Google if you want. No issues with that. So what is cloud computing? So this is a definition. We start with a definition. Don't need to memorize it. I'm not going to ask you define cloud computing. Okay. My course will be more hands-on course. Okay, so you don't have to uh, like cram anything. Okay, but I want to tell you about two properties of the systems that are inside cloud. So it is a specialized form of distributed computing, okay, that introduces utilization models. So this is also important. Utilization models for what? Remotely provisioning scalable and measured resources. So utilization models for resources basically. But what kind of resources? That are remote. So you need to provision or you need to create or manage. Provisioning means creating, managing, closing, right? Them remotely, and they need to be scalable. So one of the fundamental reasons why cloud computing came into being is scalability. You can reduce your load, you can increase your load, that we'll discuss a lot. Scalability is the key benefit that cloud computing provides over regular data center or server rooms that we have like in DICT, right? So it's a distributed computing that tells you utilization model, mean how you will utilize the resources. Utilization may it will come the costing will also be very important, right? Because as remember, cloud computing is all about return on investment like any other business. So whatever resources I'm trying to use in cloud, there is a cost associated with that. I as a business I am paying to Azure, I am paying to Microsoft because I'm using their resources. So I don't want to pay unnecessarily. I want to pay only the minimum that is required. So that is why there will be utilization model. I want to my engineers, people who I have hired, that be aware of how to optimize the use of the resources, because I want to conserve the pay that the money that I'm paying to those resources for those resources, right? So we will learn a lot about utilization models, and I will urge you to keep this in mind. Two things, right? One, we discussed that every cloud service, for the recording sake, now I'll tell again, Every cloud service, because it is a modern software, came out, I think, in after in the late first decade of 2000s. So every cloud service that is provisioned, that is available for people to use by Azure, by AWS, there is a business reason for that. So as a software engineer, as a skilled developer who knows about cloud computing, first thing you should know what is that service and how to use it, definitely, because that is the prerequisite. But also try to understand why that service is there, which business reason it is for, what business problem it is solving. Okay, that is uh, one thing. Now, second, the cost associated with that. The first question you should answer is what business problem it is solving, and second question is, if I'm using this service, how much it is going to cost me. Always keep cost in mind. Why? Because it can give you promotion. Because if you know how to reduce the cost and that becomes visible, obviously it will become visible when the bills will reduce to any person, anything over you, manager or CEO of the company, they will promote you, right? They will promote such people who are saving money for them. So always keep cost in mind when you are discussing or thinking about cloud computing resources. Always keep try to understand why that service is there. So utilization models basically relates to cost. So we need to utilize the resources or create the resources remotely uh, on the cloud and create them such that they are scalable. Okay, and what is the utilization model? How we can use them? Okay, so when we want to create remotely, then obviously we'll have to use some tools or some interfaces that are available either through the website of Azure or AWS, right, or through some scripts or through some command lines, right. We cannot go to the data center of Azure and switch on a computer thing saying that this is now my machine, right? Not cannot happen. So we need to remotely provision the resources. So that is why cloud computing is a specialized form of distributed computing that introduces utilization models for remotely provisioning what scalable and measured resources. Now, measured means obviously when you have utilization model, like when I say you should be aware of what the cost will be of the resource that you're using. Obviously, you will need to understand how it is measured, right? Otherwise, how will you know what is going the cost going to be? So if you create a virtual machine, you use it for 10 minutes and you use it for 59 minutes. The cost is same because it is based on the number of hours that you use. So it will be costed not in 10 minutes and 59 minutes. It will be 1 hour. Per hour it is. Okay. So things like that, a lot of such details are there which we want to be clear. And I added this platform services is because now not only resources in terms of, let's say, virtual machine which I can use it just like a computer, there are platform services like I can there are APIs available that I will call from my application code to use those API which are running on the cloud. So it's like a platform. It's like I'm building an application for Windows. Windows is a platform because I'm using the API provided or the components provided by the Windows or .NET or some technology, Java, right? So these things, platform services are also part of the cloud computing, and that platform services also become more relevant when we have this the perspective of where is that developer and architect perspective. Then platform services become more useful. Okay, remotely scalable and then platform services. Now, what is the motivation? Why should I use cloud computing? Right, it's a cool thing to do. It doesn't matter if it is cool or not. What matters is, does it give me more return on my investment. That is the only reason why somebody will use cloud computing, right? So the what are the drivers or what is the motivation of using cloud computing? Now, for that, we need to understand why, what are the problems that the current or a world without cloud computing is facing. And once we understand that, then we will see how cloud computing is trying to solve those problems. And obviously, if my business problem is getting solved, I am interested in that technology, right? That is how the motivation comes to use cloud computing. So we need to discuss about capacity planning, cost reduction, and organization agility. So capacity planning. What is really capacity planning? What I deal with, what I'm talking about capacity planning is about the hardware capacity. Okay. So when companies hire resources like students from our college, what are they doing? They are adding the capacity, right, of human capital for developers that will be used to solve program problems by writing software, right? So they are adding the capacity of human capital. Similarly, the infrastructure, if I hire 10 people and I don't provide them computers or infrastructure, then how will they work, right? So I'll need to add the capacity to my hardware also. So now imagine I am trying to uh, launch a website, okay, and it does some interaction with users. It registers them. Let's say it takes some money from them for some service, and then payment happens, subscription happens, things like that. So I, because the users who are coming to my website are potentially my customers, they are going to pay me. I don't want uh, any user to launch my website and then keep waiting for it to load, right? So what is happening in the behind the scenes? The behind the scenes, there is a web server, right? Which is, let me check if my digital pen is working. Not yet. Just give me a second. Okay. So now I'll draw it here. So what is happening is when a user is opening a website on the computer, right? So there is a website here. What is happening in the background is through the internet. This is internet. There is a web server running here, and this is hardware, right? At end of the day, whether through cloud computing or not, there must be some physical machine on which the computer is running. This server is listening to requests through this internet. The REST API or HTTP calls are coming, right? HTTP protocol. So it is listening to those ports, and some request comes, input comes, some code gets executed, right? This is the request handling, and then the response is sent back. So it means for every request that comes, we get to execute some code, right? So when there some code execute, that code might be talking to a database in the background, right? It might be talking to some other service in the background, like let's say some payment gateway, other service, things like that, right? Point is, from the incoming request to the point when the response is ready for to go to the output, response is ready, there is a time lag. So there is a time gap between input, sorry, it's the opposite, I, the input and the output this side, right? So time gap. So during this time gap, what is happening on the page that the user is seeing? Can somebody tell me? During this time, when the input has come and response is yet to be sent, what is happening on the website? The user is seeing. Anyone?
The page will be loading.
Yes, absolutely. So the page will be loading, user is waiting, right? User is waiting, which is a very poor experience. The waiting time should be as less as possible, right? Now, obviously, one way to reduce this, one way, like what I have described, this time gap, how can I reduce it? By building a faster computer. But let me bring this to another aspect so that we it will align with capacity planning more. This time gap could be also because there are so many requests coming. There are so many requests that are coming from input side that this guy is getting busy because of that. Okay, there's so many of requests, right? So because of this large number of requests, I am getting my users are waiting for a lot of more time than required, and obviously nobody wants to wait sitting on in front of computer and nothing happening, right? So I risk losing my customers. So what I do is I provision more web servers so that I can distribute this load of the request on two. Same code runs on both web servers in parallel. There is some synchronization mechanism, but I, at the larger picture, I have distributed a load between two web servers, or three web servers, or four web servers. Right? How many of them should I deploy? Now that is from developer's perspective. The answer will be deploy as many as required. Right? But each web server will cost money. Right? So how much money I can spend, that is when the money comes into picture, obviously I should not over deploy, and I should also not under deploy. So that is the problem in the capacity planning, right? I need to plan for the capacity looking into the future. So how the businesses solve this problem? Before, we are talking about the world before cloud computing. So there is a lead strategy, as you can see from here. There is a lead strategy. Lead strategy is saying that what lead strategy says, it says that you add the resource, IT resource, in anticipation of the demand. The demand has not come yet, right? But you add a resource. So now let's say I experienced this issue that I just described in my first service launch. When I am launching some other service or I'm upgrading it, I don't want to face the same issue where my people start waiting. What I want to do, I will probably add these two servers before this situation comes. So this is lead strategy. I already deployed the server, right? So very good. That solves the problem. But what is the issue? The issue is that you have to spend more money, right? Two servers cost more than one server, and we'll come to more like what could happen also further. Um, Later, like we discuss when we discuss more. But lead strategy basically is this about uh, adding the capacity, which is mostly in our case is hardware capacity, before or in anticipation of the demand. What is lag strategy? Lag strategy is that we add the capacity when the existing capacity reaches full, right, which is overflowing. So I add start with one web server, keep serving the request, but when people start waiting and I start ending up, or my logs tell me that user logged in but did not do anything, and the session ended, that is an indication that the user is waited and then quit. Most likely that user is not going to come back again, right? So I now know that my one single web server is no longer sufficient to uh, serve the request. Then I add the new web server. That is called lag strategy. Your infra is lagging behind the demand or the volume of the demand, right? Now that may not sound a sound strategy, but if a service provider is what do you say, running short of money, or has a problem financing things, lag strategy might work well because it basically almost utilizes the resources to its full. There's a problem there also, but we'll come to discuss about that when we talk about cloud computing. I mean, how the cloud computing solves this problem. Match strategy. Now, match strategy is saying that you add the capacity in small increments as the demand increases. So this is match strategy, but it's not easy because it's not easy to um, add more small number of small capacity servers than adding a large servers. First of all, you are not building those servers, right? Some company, HP or Dell or some other Lenovo, they are building the servers. So you are restricted to what they are offering. So it's not easily easy. It's easy to say match strategy, but it's not easy to match because you are dependent on what you can get from market, right? So these lead, lag, and match strategies that were or are deployed or are used to handle these kind of issues that we face uh, have problems. So if we accommodate the max load, now if my this suppose this is an e-commerce site, right? I imagine I am trying to search for something in Amazon and it just keeps me waiting. I'll go to Flipkart or I'll go to something else, right? Um, to not have let that happen, um, the service provider like Amazon, suppose Amazon is poor in the beginning, they will add resources, they will add hardware, right? Now, it happened to be that so happens that e-commerce sites are more busy over the weekends because uh, people shop more over the weekends. So for that, I added, let's say, 10 more servers, such servers. But during the 5 weeks of work days, Monday to Friday, the demand is so less that even two servers were enough. So for 5 days, my eight servers are lying unutilized. That is the over expenditure, right? I don't need to use those eight servers, but they're lying over there because it's not practically possible to shift those eight servers somewhere else during the weekdays and then bring them back to use in the e-commerce side over the weekend, right? What if there's some holiday in between on Wednesday? Uh, when the demand is high, I am again going to get into that issues because my eight servers are deployed somewhere else. So it's not easy. So if we accommodate for max load, we get over expenditure. If we try to moderate the expenditure, right, by using lag strategy or match strategy, then we have transaction losses and usage limitations because our capacity is not there. So it's a huge problem, as you can see. Either way or other, we it's not easy to optimize. Okay. Then cost reduction, as always, the cost of hardware, the IT cost, is very important. It is large cost, so therefore reducing it is every business interest. Okay, so then what we need to not only mention is that it's not about only the cost of acquiring the infrastructure. You buy the server, but what about its maintenance, right? You need have to maintain it. Some power bank goes off, the power supply goes off, or some disk stops working, then you have to maintain it, right? Things like that. So that somebody has to, you have to pay somebody to observe those things, right? To replace those things. Those are operational and maintenance costs. So these two factors need to be considered by the IT guys for uh, the cost that will be incurred. So how can we reduce those? So operational overheads, that is that might look boring to us, but as you can see, it represents large share of IT budgets. Operational overhead. So how to reduce that? If you can give me something that will reduce the cost, that will reduce my IT infrastructure, that will reduce my operation and maintenance cost, I will love to grab that opportunity. I will love to use that service, right? So from that perspective, you see, it makes sense. So all these things are operation overheads, technical manpower, upgrades and patches, utility bills, power cooling, right? It's not only about the hardware running, the bill that I get because the AC is used to cool the system. they are also a cost to me, right? How do I have access, the security and access control? That also requires cost. Administrative and accounting, that also requires cost. I need to buy Windows Server license. So all these operational overheads may not be very interesting to us as developers, but for somebody whose money is getting into that, that person is interested, right? So cost reduction, if in any way can be done, uh, any business owner will welcome that. Then organizational agility. So we have capacity planning, we have cost reduction, but can my organization, can my company, can my teams as a unit be more agile? Can they be more efficient in doing what they are doing? If they can, choosing some service, wouldn't I love to use that service so that I can get things done better earlier, so that my product is launched in a better way, with more quality, in lesser time. If my product is launched in lesser time, I will get more time in the market, right? So therefore my revenue will increase. I will start People will start using my product earlier than previously, right? So if using some services, my organizational agility increases, then I would like to do use that service, right? So from IT perspective, whatever changes that are required in the business, IT needs to respond to that. Like, this is the response. We were talking about adding a new server. Who did that? My company's IT people added the service. That was their response to the business issue that the business is facing. So the IT enterprise need to respond to business change by scaling. This is scaling, right? I scaled up my server parallelly. I scaled it out to two servers in parallel. One option was to add more hardware in the same server. We'll talk about that, right? So we need to prepare for how our services can scale, right? New business require more IT resources. So how we can purchase those, how we can make them more available, respond to those changes. So it is a huge problem of uh, provisioning the resources, operational costs, and being more agile to changes. These are the challenges that the business faces while they are providing some service to us. If I am using my bank services online for my bank, somebody in that bank is worried about that the capacity is there so that I, as a user, do not get timeout issues, right? So if you are using your banking services, sometimes you will get an email saying maintenance notice. This bank service will be down for so and so hours, right? On a Sunday in the night or a Saturday in the night, some banking service is down. So they are working overnight. They are being awake such so that the customers over the weekdays do not suffer any problem. They are doing their maintenance during less work hours. But maybe Saturday night I am into a pub or something and I want to pay through my credit card. It's not working. That becomes a problem. So it is always a compromise. So these are the issues that we face as a business plan, as a business that should run all the time and cater to all the requests from customers without any downtime, without any transaction loss. That is the ideal goal. For that, all these are the challenges: capacity planning, minimal cost, and agility of the IT and other teams to respond to changes in the business. So that is the issue. Uh, why people are not able to join automatically? Anyways, so this is how the cloud solves this. So, so this is this diagram I got from AWS, but it beautifully explains how cloud solves this problem. So let us say this what we have discussed so far can be summarized in this left side chart. Okay, so I can't have a pointer. Anyways, so on the left side chart, this blue line is the capacity. Okay, blue line. This red line is the demand. So let's start from the beginning. So from the beginning here on the left side, I want to launch this service, a service which is going to be used by customers. This is red line. So earlier when I launch, I will have some server to launch into. So I already have a capacity, and in the beginning nobody is using my website, right? Then I do the advertisement and all, and people start using my service. At this point, my usage of my service is going to cross the available capacity of my hardware. So as soon as it crossed, I know I added a hardware. So I added a parallel server like I did. So my capacity now, compute power or capacity is at this level now, and the demand is increasing like anything. So if I place my hand on this graph, rest of the graph that I am already showing, okay, then if just somebody looks at this curve up to this, what will that person think or project the demand? It will further grow like this only, right? On the same line. So if we missed some portion of request here, the area under graph between red line and blue line, when red line is upside and blue line is low side, is the loss to the customer. You can say these are the customers we lost, right? So we experienced a small loss of customers at the beginning of our business also. So somebody got a good bashing, and as soon as the demand started coming towards the capacity, we added one more server or whatever, one or five server, whatever, but we added the capacity to the server so that we are anticipating this demand surge. So we can cater to by having more capacity added preemptively, lead strategy, right? But something happened and the demand dropped. Now, this area between of graph between the blue lines and the red line is a waste of resources because this area is not getting used. We have the capacity, but the demand is only this much, right? So these resources are getting wasted. The money I spent is not returning me anything because nobody is using it, right? So it is a waste. So any this is a waste, this is a waste. So when the demand stopped or reduced, and I had additional planning, again somebody bashed me, saying that why did you buy 5 lakhs worth of servers when the demand is reducing, right? My boss is my boss, right? He can uh, bash me either ways. So when the demand starts increasing again, now I am susceptible as an IT guy, thinking I cannot assume the demand will go like this. So I do not increase my capacity. I want to wait. I want to use the lag strategy. But if it so happens that the demand goes like exponentially grows, so then I have a lot of customer dissatisfaction. I realize that at this point in time, I add the servers, not enough. Maybe that server or budget is not available. I'm still getting customer dissatisfaction because the requests are getting declined, the transactions taking a lot of time, stuff like that. I negotiate. It takes time to add more servers. I add more servers, and finally, I reach that. As you can see, the challenge. Either ways, it's not happy ending, right? That is the issue we face in provisioning the resources, right? Remotely provisioning. Provisioning of the resources, that is the issue we face in the traditional data center. Data center means the server room where our servers are running, um, and we are the incoming requests are coming. Okay, what how a cloud service solve these problems. So we start with the same thing. We start in the beginning. We provision the service or compute power from the cloud, meaning we create virtual machines, you can say, and deploy our web server on those virtual machines. And we do one important thing, we set it to auto scale. So, auto scaling, what will it do? As the demand increases, the auto scaling will take care of adding capacity to the machine or adding more machines. Basically, at the web server level, the capacity of the hardware will always be a shade above of what the requests are. Okay, so we will never go out of, we will not go in the area where we have customer dissatisfaction, where our red line is above the blue curve. Okay, so at this time, at this point, it is fine, very good. The customer demand is increasing, so is our hardware in the cloud. What about when the demand decreases? So auto scaling will reduce or deprovision the resources and match the demand. So when the demand reduces, so does our provision resources. And when the provision resources are reducing, your cost will also reduce because you are going to pay only for what you are using. So if I upscaled from 1 to 4 VMs, I am paying for 4 VMs, but when the demand goes down, I remove 2 VMs, I am going to pay only for the running 2 VMs, not the ones that are removed. Right? So the cloud is able to help me by reducing the cost of the infra as the demand is reduced. And then when it increases again, the cloud has capacity because these companies are having very large data centers. They have capacity, almost infinite capacity, to meet my demand as much as required. Okay, so we get best of both worlds: no customer dissatisfaction, no waste, right? So if you see, it will, this thing solves both all the three. At least we can talk about at least the two of these, right? Even three from the IT perspective, the agility part. All these three problems are solved by the cloud computing because they can provision the resources in such a way that we scale up when the demand is more, we scale down when the demand is high, low. Okay, so it solves that scenario also. The weekend scenario. Weekdays demand is less. Weekends demand is more. No problem. Cloud can solve it for you because on the weekends it can provision the resources, then bring them or deprovision them when the when Monday starts till Friday. So it solves the problem. That is why this is the motivation, right? Cloud computing is solving business problems faced by the businesses because it reduces their cost, it manages their capacity, it increases their organization ability. Because by just flipping some button or running some scripts, I'm able to increase or decrease the resources rather than having to buy it and provision it and plug it and all and maintain it. So everything is done by Amazon Web Services or the cloud service provider. So this is the beauty of the cloud computing, right? This is the beauty of how cloud computing is able to automatically scale both up and down and keep our costs optimal. We will have to pay for what we are using, but we are using what optimally is required rather than having extra resources or customer dissatisfaction. Either ways. Okay, so we'll stop here and then continue in the next lecture. Unless you have any questions, are you getting? Are you finding it interesting? Did you understand what we spoke today in the lecture?
Yes, sir. Yes, sir.
Okay, great. Uh, One more thing I just want to tell is sorry, I can stop the recording now. So what I want to tell is I am open to feedback. Okay. So as I discussed, we want to run this course so that you are the center at the center of importance. I am interested in making you skilled, imparting you the knowledge. You should understand it. So I am open to feedback on anything, right? If you give the course feedback, like our process at the end of the course, then that feedback will be applicable to the people who are coming in the next time when I give this course, right? Not for you. You would have already suffered. So if you think we can do it in some other way, a better way, let me know. We will try to incorporate whatever we can so that we can gain the benefit of your feedback for you as much as possible. So feel free to provide your feedback, and we will try to incorporate, and that will help us all. Okay. Have a good day, guys. Thank you. All right.